My presentation is about the 2014 MLB Top 100 batters. I am investigating the performance of the top 100 hitters in the MLB during the 2014 season. The goal is to analyze the different hitting statistics to comprehend which statistics play the most significant roles for their offensive success. The StatCrunch dataset that I am analyzing consists of players' name, team division, and every hitting metric performed in the 2014 season. The dataset is forged through observational data with no manipulation of variables. It is simply natural data recorded by ESPN.com during the 2014 season. My first graphical display is a scatter plot, with X being the number of at-bats and Y being the hits recorded. The number of hits mean was 145.34, the median was 150.50, and the mode had multiple modes. My second graphical display is a histogram, with batting average, which is at-bats divided by hits. The mean was .281, the median was .276, and the mode was .272. My measure of center interpretation. The scatter plot has a positive association which does not affect skewness much. It just simply shows the more at-bats a player gets, they tend to get more hits. The histogram for batting average is bell-shaped or approximately normal, showing little to no skewness in the data. The mean is the best value to use for the histogram data because it is relatively symmetric, matching the mean. The median is the best value because the data is not symmetrical and the median is greater than the mean, hinting at left skewness. Our next graphical display is a box plot, with at-bats being the left and the hits being the right. The range for the at-bats is 424, the min is 260, the max is 684, the median is 544, the standard deviation is 95.74, the IQR is 130, the Q1 is 459.50, and the Q3 is 589.50. For hits, the right box plot, the range is 155, the min is 70, the max is 250, the median is 150.50, the standard deviation is 29.25, the IQR is 38.50, Q1 is 126, and Q3 is 164.50. The measure of spread. The box shows the measure of spread of the number of hits and at-bats using quartiles. The length of the box shows the IQR, which describes how varied the data is. The whiskers show the overall range and how far the minimum and maximum values are from the data. The standard deviation shows how far the number of at-bats and hits are from the mean of the data set. The box plot for number of at-bats has a range of 424, showing large gaps between the player with the least amount of at-bats. This explains how some players either have limited playing time or played all the time, reflecting their performance numbers. The standard deviation of 95.74 is saying the typical player is about 96 at-bats away from the mean of the data. The IQR of 130 demonstrates the extreme variation of number of at-bats spread out amongst the players. The box plot for number of hits has a range of 155, illustrating the large gaps between the highest and smallest number of hits. The number of hits standard deviation is 29.25, highlighting how far the average player hit total in the top 100 list is from the mean. The IQR of 38.50 reflects the middle players aren't super far or close to the worst and best players in the dataset. Correlation and regression. The scatter plot, the X value is home runs and the Y value is RBIs. R equals 0.851. The least squared regression line is Y equals 34.21 plus 2.06x. Slope equals 2.06 and R squared equals 0.724. In my scatter plot, the X value is the number of home runs hit and the Y value is the number of runs batted in. The scatter plot shows a strong positive linear relationship with a tendency that when home runs increase, runs batted in will follow. The slope of 2.06 tells us that for every home run hit by a player, the data predicts their RBI total will increase by 2.06 on average. This shows a positive association between the number of home runs and RBIs collected. The coefficient of determination being 0.724 shows that on average 72.4% of the different ways to get an RBI amongst the players can be explained by the amount of home runs they hit that season. This demonstrates that the home runs is a big factor for how many runs batted in a player will have. My prediction is that if a player hits 35 home runs in a season, he is projected to collect 106 runs batted in for that year. This projection is very reasonable because when you plug in 35 for the least squares regression line, Y equals 34.21 plus 2.06 times 35, you get 106.31. rounding down to 106. My probability questions are: what's the probability that a player in the top 100 hitters in 2014 had a WAR of at least 7 and a minimum 30 home runs? The probability that a player has both is 0.004 because there's a 10% chance a player has a minimum of 30 home runs and a 4% chance a player has at least a 7 WAR, accounting to 0.004. My next question is: what's the probability of a player in the top 100 hitters in 2014 has less than 30 doubles and less than 5 triples? The probability of both events happening is 0.3876, or 38.76%, because there are 76 out of 100 players with less than 5 triples and 51 out of 100 players with less than 30 doubles. 0.51 times 0.76 equals 0.3876. My discrete probability distribution, base on balls, and P of X. From 0 to 20 based on balls, P of X is 0.04. From 20 to 40 is 0.31. From 40 to 60, it's 0.36. From 60 to 80, it's 0.2. From 80 to 100, it's 0.07. And from 100 to 120, it's 0.02. My discrete probability distribution graph shows the very same metrics as the distribution in just graphical form. Inferential statistics. My first hypothesis is the proportion of top 100 MLB hitters in 2014 who hit 20 or more home runs more than 50%. We are 95% confident that the proportion of the top MLB hitters in 2014 who hit 20 or more home runs is between 0.94 and 0.486. The entire confidence interval is below the proportion of 0.50, so there is no evidence that more than half of the top 100 MLB hitters in 2014 had 20 or more home runs. H0 is P equals 0.5, and HA is P is greater than 0.5. The p-value came to 0.986 and the z-stat came to negative 2.2. Because the p-value 0.9686 is much greater than 0.05, we failed to reject the null hypothesis. There is no evidence that more than half of the top 100 MLB hitters in 2014 hit 20 or more home runs than the p-value. 0.986, being significantly smaller, suggests it does not support the claim at all. My second hypothesis is the mean number of hits by the top MLB hitters in 2014 less than 150. We are 95% confident that the mean number of hits by the top MLB hitters in 2014 is between 139.54 and 151.14. We do not have strong enough evidence that the mean number of hits for the top 100 MLB hitters in 2014 is less than 150. HO, U equals 150. HA, U is less than 150. The p-value comes to 0.057. The t-stat is negative 1.593. Since the p-value 0.057 is greater than the level of significance 0.05, we failed to reject the null hypothesis. There is not strong enough evidence that the mean number of hits for the top 100 MLB hitters in 2014 is less than 150. Even though the sample mean is somewhat below 150, there is not strong enough statistical evidence at the 0.05 significance level to support this claim.